So my name is John Casperin. I'm with Tata Consultancy Services, and what I'll be talking about today is distributing client environments. Distributing client environment provisioning and test automation execution within the cloud-based environments. Now, what you might be asking yourself is, what is that? So, what that means is that in DevOps, we have continuous integration, continuous delivery, but as part of that, we have continuous testing. And within our testing cycles, you're talking unit testing, you'll have functional testing, regression testing, integration testing, performance testing. But we want to have that automated. But the problem is that with a lot of older technologies, you'll have client environment like thick client applications, terminal emulators, and then for the distributed, like newer type technologies, you will have modern web applications that are web UI based. So how do we get and build a client environment for those integrated type scenarios where I have one component that is a mainframe terminal emulator, and then one component which is my web application? So to really spell this out is that for these environments and for the development and for the testing, it all ties back to our requirements. So how do we tie that all back together? Is that when I have a requirement like an Agile Central for a user story, is that I'll have a requirement that I have to develop code and make a change. And then also for that change is that I need an environment for my test cases to execute in, a client environment. I also have an application environment that the application has to be hosted on. And then finally is for my automated test cases, I have to build a test case to test the requirement. So what we've built is for those client environments and for our automation scripts is that we want to ensure that our client environments are exactly matching what the app or the automation scripts require. So like if we're talking about a web application, Chrome, Firefox, IE. If we're testing different versions to make sure our web application works in different revisions of it, we have to make sure our environment has the right software version like of Chrome so that we can test and make sure it works. Or if we're talking about a thick client, maybe an old VB6 app or an ASP.NET app, is that I have to install the correct version of the application that my developers just changed so that I can ensure that it is working properly. So what we've done is that whenever there's a code deployment into a region, say for system testing, is that what we'll do is that we will pull that information, our test cases from ALM, which have all of our requirements in it, and then we will automatically and dynamically determine how many virtual machines are required to reduce my time cycles of my test execution. So with that is, when we determine each machine, we also know what configuration, what environment configuration, and what testing tools are required. Because the whole point of this is that I have a requirement and I need to test it, whether it's Agile or Waterfall, doesn't matter. I have a requirement I need to test. Now for Agile, is that in sprint testing dictates that in the sprint, I need to execute everything automatic, use automation, and everything is much faster. And Waterfall is, when I do a release, I do my testing. The only difference between two is in Agile, you're releasing a lot quicker. So everything has to be automated. Automation can't be attended. Lastly is the other problem within an enterprise or within an organization, say a Fortune 500 company. They have multiple divisions. Each division has their idea of what test automation is or what development is, and they use different tools. Like for instance, if we're talking about UI testing, we may have Selenium, we may have CA DevTest, which I will say I love. Then Then we have HPUFTs, smart bears, test complete product, and the list goes on. But the problem is that each one of those tools execute or is triggered differently from each other, and it reports in different reporting structures. So how do we get, from an enterprise standpoint, everything to execute under the same umbrella? So that's what the solution gives, is building your client environments automatically based upon your requirements, and then executing the test cases. And it doesn't matter what type of tool it is, because you can expand to use any tool with the solution. So the execution process goes that we trigger the engine. So from our deployment tool, it could be TFS, udeploy, Jenkins. It will send a trigger to our Jenkins pipeline that will start this process. Next is we'll retrieve all the information from the test information from ALM. And it doesn't have to be ALM. Here in the near future, we'll be using Agile Central, as the organization I work for currently is going to Agile. Third is that once we have all the information, we have an algorithm that executes and determines how many virtual machines we need. Then the algorithm will send a payload to Ansible, which is a Red Hat tool that does environment configuration. And so what we do is we let Ansible take that and then spool up the machines, configure them, but lastly, and the most important thing, is validating the environment. So I want to make sure that every single last piece of software is installed with the correct version. I want to ensure that all my environment configurations, folders, file paths, utilities, jar files, everything is perfect before I execute my test script, because if it is not perfect, my script is not perfect, because my script is dependent upon the environment. Then once we validate the accuracy of the environment, then we will then execute the test scripts. Once they are automatically executed, then we will report the information back to ALM and in the future Agile Central, and then we will decommission a machine, because we only want to use the cloud infrastructure as long as we just need a test. That way it's always performant and we're not degrading for the rest of the users within an enterprise. So as I said before, the first thing is that we will have to call ALM. We make 5 separate calls, and Agile Central is very similar to this. We will first authenticate and create a session. Once we do that, then we'll retrieve all the test set information. This will tell us all of the unique test cases underneath that test set. Once we have that there's parameters that are on each test case. These parameters tell us the type of testing tool, the type of environment or client environment configuration I need to make. It tells me where my automation script is stored in Git. It tells me how I'm to execute that test script. Now, what I mean by how to test that is some scripts, if we're talking legacy applications, have to be executed in sequentially, meaning that there's batch jobs that has to be one after another, after another, after another. Or you have modern applications, which we do a lot with DevTest, is simultaneous execution, meaning each one of my scripts are independent of each other and I can execute as quickly and fastly as I want to reduce my time cycles. So once we have all of this information, we generate a normalized format, a JSON payload, that will be sent into Ansible and allow Ansible to start building and configuring the machines. So once Ansible has that, before Ansible has that payload, we have an algorithm. What this algorithm will do is, take this example here, is I have 20 test scripts. And for those test scripts, it composes of 2 applications. Application 1 and application 2. Application 1, as you can see here, we use 2 testing tools, DevTest and UFT. So it's a mix, it's one of those situations where we have a legacy application and a distributed application together, 2 different components. However, you can see here that for UFT scripts is that they're marked as sequential. Sequential execution means that I assign all of those test scripts onto one machine and only one machine because they execute sequentially. So I only need one virtual machine. However, For all additional scripts that are assigned as simultaneous, is that we have a very basic algorithm that says, I want to execute all of my scripts within 120 minutes, say 2 hours. I want to execute all of my scripts. What we'll do is each script is identified with an average execution time. So as the QE individual or quality engineer has built that script, they've identified it took about this long to execute. So what will happen is that we'll take the average of the bunch of simultaneously executed scripts and say how many of these scripts can be accompanied on one machine so that it executes under 2 hours. And so what we find is how many machines are required for that simultaneous execution. So for this example here, you can see that for my application 1, for all of those 16 scripts, they execute an average about 30 minutes. So that means that I can accompany 4 scripts per machine. So that means I got 2 machines. So after this all is said and done, then we will have a total of 4 machines required for this execution. So once that's done, as I briefly pointed across, is that Ansible will send a normalized JSON payload from ALM and our algorithm to Ansible. And in here you can see that this is all the information we've pulled from ALM, all of it. So what's our test set ID? Then what testing tool, what application, and then for each testing instance or test case is where is my project located in Git, where am I pulling it to? For DevTest, as an example, is you have a test script that says how am I supposed to execute. You have a project configuration that says what environment am I executing that test script on, and a staging document that says how is DevTest supposed to distribute the execution across simulators. So Ansible will then, after taking that payload, will start to build the machines. And so just without getting into too much detail, what happens is Ansible will communicate through Kerberos and will establish a ticket and store the security credentials on the Ansible node itself, so that every time for each machine that we connect to, is that once we have that ticket and it's stored on Ansible node, Ansible can connect to WinRM, our Windows Remote Management, and able to keep the session open for as long as we're running the test. So once we establish that connection, so our Ansible scripts also contain PowerShell scripts. So because we're working on Windows hosts, we use PowerShell to run all the configurations. And so what will happen is that PowerShell will first reach out to a binary repository. We've been using Nexus, but here in the near future we'll be moving to Artifactory. Because the reason why is Artifactory has a better way of adding tags to the binaries. So when this is executing, I can provide the tag during the execution and say this is the version I want to execute. Because if you're looking at historical automation, what if there's a production issue? And I want to rerun old automation. With my old automation, I know exactly what version I had used previously for an old release. So once this all gets going, then PowerShell will then install the software, configure the software, validate the software, and then we'll start the execution. So once everything has been validated and we're ready to execute, so what we do is that we have a trigger machine. It's a centralized machine that Ansible will interact with and is responsible for triggering the automation scripts. So for DevTest, what we do is every time we install DevTest server, it comes with a service called Test Runner. And what that does is through command line, we'll instruct the DevTest registry saying, I want to execute this test script with this configuration in this staging document. And so then DevTest will pick up all the information and then go on and do this execution. Second, is for HP UFT, it's a tad bit different, is that for UFT we have to first set up a remote desktop session so that we have an UI to interact with. DevTest is headless. It does not require a desktop session to be started to be able to run. But for UFT, it does require that, so we have to start a remote desktop session to start the execution. Once that's been started, then we have a VB script that will configure UFT's configuration settings and then start triggering the execution of the scripts one by one. So as they're executing, one issue we ran into a long time ago is scripts have a lot of dependencies. So for instance, what I mean by that is if we look at UFT, is that UFT uses Excel sheets, always has. But the problem is that for a modern software factory, as everybody's been saying it, is that you should not have to touch the automation to get it to run. So like all of our UFT users, what they would have to do is every time that the developer said, okay, the code is done deploying, they have to go in, open up the UFT script, they would have to go into their Excel sheet, they would have to go change the indicators saying, I want to execute this one, this one, this one, this one, this one. That does not work. Because you want the deployment tool to trigger the automation instantly. So what we've done is we've externalized all of the requirements for that script to execute. For instance, number one is your data. Your data for your automation script should always be on the outside. It should not be contained with the code of your script. Because your scripts should be dynamic, meaning that as I'm executing it, I'm filling in the data required for that one scenario to execute. Second is environment configuration file. It means that inside my data, I should never have environment variables. I should not have server endpoints, user IDs, passwords. If I'm testing on one region, I have a series of environment configurations. And then lastly is number three, is that when I execute my automation test script, I only execute one test at a time. What I mean by that is multiple tools, like DevTest is one of them, is that DevTest has the capability of pulling in a whole bunch of data and distributing across the simulators as it's kind of like a load test, but we can use it for functional testing too. And so it has that capability of doing that, but it becomes very difficult to parse out its report and get that and tie it back to a single test case. So here is that, can everybody see my, oh, no. So if you see here on the right here, is that from ALM, we have our scenario number. This comes from the unique IDs of your test set and the unique instance. And we pass that through and put into our project configuration, which has a property called scenario number. So what happens is that we can use the same automation, automation script and configuration to execute all of our scripts, but we're just dynamically passing in the one test case that we want to execute at a time. So we have a one-to-one mapping. So going back to my original. My requirements are tied to my development, to my environment configuration, and then my automation script. So there should always be a one-to-one mapping. So once it's all said and done, then we generate the execution report. So here, as you can see, is that at the very end is that we will take the report from DevTest, UFT, and we will parse it with the Groovy script. And then those results are uploaded directly to the test case that we had pulled those original requirements from, so that we have that one-to-one mapping. The reason why this is important is because we want to report to the portfolio people saying this is the automation that was executed as part of this deployment. So with this is that now we have the ability of staying with the waterfall people because they're still behind, and they're still using these archaic tools like UFT. And then you have more agile teams who are, I see you guys laughing over there. Then you have like newer teams who are doing more, or using automation tools that are more agile, like DevTest that uses Selenium, so that we can, in the same sprint, build the scripts, make them dynamic, execute them as part of the deployment within that sprint. Because if you look at, I don't know how many people here work in or are agile yet, but for my, yeah, anybody want to raise their hand who does agile? So, I mean, my own personal experience is that in sprint automation, roughly about 4 to 6 code deployments per sprint. It depends on the type of application, especially like cloud-based deployments where you can take user story all the way to production. Is that your automation, your quality engineers have to be working directly with the developers and have to have all of this set up in order to be able to run their testing cycles as part of that sprint.